Hello guys, we're back. Okay, so now let's continue with fluid motion and Bernoulli's equation. I think if you have read the slides, there might be some explanation that you might feel confused. So I'll try my best to explain this way. Okay, so for the fluid motion and Bernoulli's equation, it's now related to the fluid flow. So for the equation of continuity, there are two parts. We have equation of continuity and also Bernoulli's effect. So let's look at equation of continuity first. So equation of continuity is related to the fluid flow. So to derive for the equation of continuity, so we will refer to this figure, okay, related to when the fluid flow from this side, okay, it will have some velocity, okay, go through this cross-sectional area, and then you will see that it narrows down to a smaller area. Now the speed will be different, so we want to find out what is the relation between the area and the speed. So what you should also know that, okay, for a given time interval for the fluid motion, okay, the mass will be the same. Okay, the mass will be the same. So I wrote it here as well. For a given same time interval, mass of the fluid flow will be the same. So what you can see here for the time taken at this part and this part should be the same, then the mass will be the same. So you put delta m at 1 equals to delta m at 2. So since mass is equal to volume multiplied with the density, so you will put it here, v1 and then rho equals to v2 with rho. So note that here is the volume. Okay, so here P is the same fluid that flow, so that means if the water flow from this direction through this area, that means the same water will flow out from here. So density here will be the same. So since volume is equals to A multiplied with the height, so height here is defined as similar to if the fluid is moving from this point to this point, so that means it's the distance. So height is equals to velocity multiplied with the time interval. So here is the velocity, so I should put an arrow to this part, okay, to indicate that this is volume. Okay, so what you will have there is, okay, then you will see, since volume is equals to A multiplied with height, then you change this height into the equation, so you will get all this, and then you will also have this on the right side. So since density and density is the same, so you can cancel, time interval is the same, you can cancel. So what left is the area and the velocity. So this is what you call as equation of continuity, expressed by the equation A1 V1 equals to A2 V2. So when to use this equation is when you need to find the speed when the cross-sectional area changes, when the fluid flow. Okay, so that is the first part. Okay, now comes the second part. So the second part is related to the Bernoulli's effect. So I would say that it is an application. Okay, personally I think it is an application of work, energy and pressure to the fluid motion. So they are related with the expression written as the first component is pressure equals to rho half rho v square plus rho gh equals to constant. So if you can recall this, the first component is actually pressure, the second component is similar to kinetic energy, the third component is similar to potential energy. So in full form you can write it this way, p1 plus half rho v1 square, so this is velocity, plus rho gh1, and then P2 equals to half rho V2 square plus rho GH2. So I think in the final exam this will be given, but you have to know how to use it, okay, because the equation is quite long. Okay, so there are actually three cases when you need to use this equation. So the first one is for the case 1 where you have horizontal pipe. So in the horizontal pipe you will have no change in speed and you have change in speed, you have change in speed but no change in height. So how do you see this? Okay, this is the reference of the pipe. So this is where the fluid will flow continuously horizontally. So what you will have there is V1 is not equals to V2 because of the area is different. So since you have no change in height, that means the third component is now equals to 0. Okay, so you just write P1 plus half rho V1 square equals to P2 plus half rho V2 square. So how to find V1 and V2? You can also use the equation of continuity. Okay, for the second case, you have elevated pipe. So for the elevated pipe, you have change in height but no change in speed. So it is illustrated by this figure. So V is taken as the same because there is no change in the area. Then you will have height change here. That means for the equation again, look at the equation again. Since there is no change in speed, then you can take this as 0. So you can write again for the second case, you have only P1 plus rho GH1 equals to P2 plus rho GH2. So this is the second case. For the third case, so you just combine case 1 and case 2. You have change in speed and then you have change in height. So when the area becomes smaller, okay, so you have V1 and V2. For the speed is also different. Then you have also change in height because it is elevated. Then what can you do for the Bernoulli's equation? You take all components. So it will be P1 plus half rho V1 square plus rho GH1 equals to P2 plus half rho V2 square plus rho GH2. Again, how to find V1 and V2? You might use the equation of continuity. So I hope this helped, and enjoy your studies.